Okay, so uh, first I will discuss this question of assignment, and after that we will start our topic. And these questions are very good question, I will say. Okay, so hmm, these are the previous year CBSE question. So first I will solve this question. Hmm, okay, fine. So this question is very easy. So see the question, first read the question, and the question says that this question says that they are saying the potential difference across the terminals of a battery is 10 volt when there is a current of 3 ampere in the battery from the positive terminal to the negative terminal. So we have a battery like this. Suppose this is a positive terminal, this is a negative terminal, and this shall have the internal resistance. So this battery. Okay, suppose this E capital E is the EMF, small r is the internal resistance of this cell, and current is flowing from positive. Current is
Yes,
flowing
sir.
from
From
positive to
positive. So it
positive.
is discharging.
Yeah, this condition is of discharging.
Yes, sir.
And they are saying this EMF is given as not EMF. They are saying that terminal voltage is given as 10 volt. So here V for this is 10 volts. And they are saying that current in this case is 3 ampere. So 3 ampere current is flowing. So for the discharging, what is the equation of terminal voltage? E minus I R I E minus IR. So V is given as 10. E we don't know. I we know 3, and R we don't know. So this is our equation 1. This is our equation 1. And they are saying after that when the current is 2 ampere, when the current is 2 ampere in the reverse direction. In the reverse direction means this time here the current is from positive to negative. Now reverse direction means the current will be from negative to positive. This is the battery we have, and this time the current, this is the positive terminal, this is the negative. Current is like this. Current is like this. So this is the charging condition. So for the charging condition, we have the terminal voltage as E plus IR, and here terminal voltage is given as terminal voltage or terminal potential difference is given as 15 volt, and current is 2 ampere. 15 volt is given, and current here is 2 ampere. So this is 15, this is E, plus I is 2 into R. This is equation second. Now when you will solve equation first and second, this is your equation first, this is your equation second. Now we will solve equation first and second, and we will get the answer. Can you solve the equation one and second by yourself?
Yes, sir.
So this is our equation.
Sir, the
Just solve by yourself.
yes, sir. Yes.
Very easy. I am solving it here. Okay. So this is the equation second. So what we have to do, we will just subtract both the equation. We will just subtract both the
Yes.
equation. Subtract this 10 minus 15, you will get minus 5. When you will subtract this e minus e, you will get 0. And when you will subtract minus 3r minus 2r, you will get minus 5r.
-5.
So minus minus cancel, r you will
Yes, sir.
get 1 ohm.
1. Yes, sir.
So this is your answer.
Yes, sir.
This type of question you will get in your examination, and I will give you the time for noting. Uh, After this, I want to discuss this question.
Yes, sir.
So question solving is very, very important because we know the theory, we know the concept, but in question, we have to apply that theory and that concepts. Okay, so this is a
Yes.
question. Here, three cells are connected like this. Three cells are connected like this, and they have the internal resistance. This cell has the internal resistance R. Suppose three cells are connected. This has an internal resistance R. This has an internal resistance 2R, and this has an internal resistance 3R. This is given in the question, and this is positive and this is negative, positive and negative, positive and negative. So means all cells are connecting in series. Means negative of one cell is connected to positive. Negative of one
Yes,
cell is
sir.
connected to positive. So how you will calculate the equivalent EMF? You will just add all the EMF. E plus 2E plus 5E means this time if you will take the direction of current like this, so in all the cells the direction of current will same. Current direction of current will be same. So means all the cells you will take either positive or negative. You will take. Okay. So here you can see that if you want to calculate E equivalent, so this is the here all the cells are in charging condition. So if all the cells are charging condition, so you will take same sign for the EMF. So I am taking the positive sign. So what will be the E equivalent? E plus 2E plus 5E. This will become 8E. This will become 80. And what is the R equivalent? R equivalent when you will add this R, this R, this R plus 2R plus 3R. R plus 2R plus 3R. You will get 3 is 6R. 3 plus 3 6R. Now you have to calculate in this question, find the expression for the current. So the current, this current you have to find. And what is the value of current? Current is equivalent EMF divided by the equivalent resistance.
Yes, sir.
Divided by the total
Equivalent
resistance.
resistance. Yes, sir.
And what what is RE? RE is equal to total internal resistance plus this
plus
resistance.
external resistance.
Plus this external resistance, this you will take. Okay. So
Yes, sir.
you will write I is equal to 8E divided by this RE is RE plus R. Now I is equal to 8E divided by RE is 6R plus this R. This is your answer. So this is of I think a 2 marks question.
Okay.
And this question has appeared in 2010. So you can decide whether you can solve this type of question or not. You can solve easily this type of question. So this is the question
Yes,
of your board exam. So this type, and now there is one question that I want to solve, and I will say this is little bit lengthy question, but we will solve it. You have the habit to solve the questions. Okay, so this question has appeared in 2008, 2010, 2015, again and for in 2010 and 2011. So see how much time this question has appeared in the examination. So let's see how I will solve this question. So first we will read the question and then we will solve. So, and I will give you the time for noting all these things. Okay.
Yes, sir.
Just So just see, they are saying two cells of EMF E1 and E2 having the internal resistance R1 and R2 given here are connected in parallel. These cells are connected in parallel, means end-to-end connection is parallel connection. Deduce the expression for the equivalent EMF. Deduce the expression for the equivalent EMF and the equivalent internal resistance we have to find. So are you getting the motion of my cursor?
Yes.
Okay, fine. So internal actually we have to find E equivalent and we have to find R equivalent for this type of combination. Okay, just see this. Equivalent internal resistance of a cell which can replace the combination between the point V1 and V2. Between the point V1 and V2, we have to find the equivalent EMF and the equivalent internal resistance we have to find. So both the cells are different. Both the cells are different. These cells are not identical. So what we will do, just focus here. This I is dividing as I1 and I2. So I can write I is equal to I1 plus I2. This is equation 1. Can I write this? This I is dividing as I1 and I2. So I can write I is equal to I1 plus I2. Can I write, Harsh?
Yes, sir.
Okay, fine. Now see the direction of current. This is the positive terminal. This is the this is the negative terminal. This is the positive terminal. This smaller terminal is negative. This is positive, and this is negative, and this is positive. So see here from here the current is from positive to negative. So this cell is discharging.
Yes, sir. Positive, negative discharge.
And tell me, what about this? This is charging or discharging? See the direction. See the direction of current. The current is going from positive.
Yes, sir.
So
Sir, it's
this
discharging,
means,
sir.
yeah, discharge. Very good. So can we write the equation of terminal voltage or potential difference for this cell? Means
Yes, sir.
potential difference for cell 1 means I am representing it V1. Here V2 is the potential difference. So for V1, what you will write? V1 is equal to E1 minus I1 into R1. This is equation 2. Okay. And this is equation 2. And for V2, you will write E2 minus I2 into R2. This is equation 3. Now what you will do from here, what you will do, you will find this I1. You will find this I1. You can find this I1 like V1 minus E1. And one thing more I want to add here. Before this, I want to add here. This combination is parallel combination. So the potential difference of this cell, or you can say the terminal potential of this cell and of this cell 2 will be equal because both the cells are connecting in parallel.
Yes, sir.
Both cells are connecting in parallel. Both cells. Both cells connected in parallel. So terminal voltage is same. Terminal voltage is same means V1 is equal to V2, and let's say this V1 equal to as V1 this, say this. So you will have the equation V is equal to E1. Okay, no problem. So now we have the equation V is equal to E1 minus I1 into R1. So from here we will find I1. So V minus E1 is equal to minus I1 into R1, and from here when we will find I1, we will get E1 minus B divided by R1. Okay, Harsh, from this equation,
Yes, sir.
suppose
Yes, sir.
this is equation 3, and you have one more equation, E2 minus I2 R2. When you will calculate I2 from this equation, so you will write E1 minus B divided by R2. So can you find na I1 from here? This calculation you can do na by yourself. I have written this directly.
Yes,
See
sir.
how you will find. I am just solving it. You will write here V minus E2 is equal to minus I2 into R2. Okay, now you will take minus common, so you will write E2 minus V is equal to I2 into R2. Now from here you can calculate I2 is equal to E2 minus V divided by R2. So I have written here. So we have I1 now, we have I2 now, we have I1, we have I2. So we can put I1 and I2 in this equation. I is equal to I1 plus I2. We have equation 1. We can put the value of I1 and I2. What is the value of I1?
I1 is
This is E2, na? This is E2.
yes, sir.
So I1 is E1 minus V divided by R1.
R1, right? Yes, sir.
Yeah.
And
And
I2 is
mhm,
E2 divided minus V divided by R2.
yeah. So now we will solve this equation. Now we will solve this equation. So just solve this equation by I'm using some different color. Okay. So this is E1 divided by R1 I can write, and this I can write V divided by R1. So for this I can write E2 divided by R2 minus V divided by R2. Now further you will solve, you will get E1 divided by R1 plus E2 divided by R2. You will just add this E1 by R1 plus E2 by R2. Now after you will solve, you will take common V, you will write here 1 upon R1 plus 1 upon R2. Okay. So
Yes,
just
sir.
now what I want to write V equivalent is equal to E equivalent minus I into R equivalent, means small r equivalent. In this form I want to write in this form. So for this circuit, for this circuit, the equivalent equation will be like this. This is the equivalent equation. So suppose this equation as A. So now just calculate it further. Take the LCM R1 R2. This will become E1 R2 plus E2 R1, and here also you will get R1 plus R2 R1 R2. Now we have to find this V. So I am taking this I minus, this will become E1 R2 plus E2 R1 divided by R1 plus
R1 plus
R2. This is minus V R1 plus R2 divided by R1.
R1 into R2.
Okay. Now take minus common from all the sides, then you will get here. Okay. When you will take common, then you will write this E1 R2 plus E2 R1 divided by R1 plus R2 minus I. This will become positive V R1 plus R2 divided by R1 into R2. Now this is I. Now you will calculate this V. Now you will calculate this V. For calculating this V, what you will do? You will just divide this. You will have this. We will have this, and we will divide this with this. This with this, and
Yes, sir.
also we will have minus I, and we will divide this with this. So this is the thing we have. So now how we will solve it? So this is V, and oh sorry, here is this is R1 into R2. Okay, this is R1 into R2. This is R1 into R2. R1 into R2. Okay. So Harsh, when you will solve this, so this R1 into R2 and R1 into R2 will be cancel out. So you will get here E1 R2 plus E2 R1 divided by R1 plus R2 you will get, and here you will get I. You will do the reverse of this, R1 R2 divided by R1 plus R2. Now you can compare this equation with this equation. V is equal to E equivalent minus I into R equivalent. So what is the value of E equivalent? E equivalent is this. When you will compare both the equation, you will get the equivalent as this. This is E equivalent, and R equivalent, when you will calculate, you will get
R1 R2
R1.
where R1 plus R2.
So this is, I think, a 4-mark question in your exam. You have to solve the equations like this.
Okay.
So this is the equivalent equation of circuit. What is this?
Equivalent
This is
equation of circuit.
yeah, equivalent equation of circuits. E is the E equivalent. E is the E equivalent. So in this way, you can write. So just
Yes, sir.
copy all these questions, and I think all questions are good questions. And the last question, I want that you should revise that last question
Yes, sir.
at least 2 times.
Okay, sir.
Yeah. Just try to write as fast as possible. Okay. Written, Harsh? Harsh copied?
Sir, I was writing the questions here.
Okay, okay. Actually, these questions you can get from the portal.
Yeah. Yes, sir. Sorry, sir.
Yeah. Okay. So actually, these are the questions of assignment. So what you should do, you can get the questions from the portal. You can
No, sir,
download the
because
question.
I didn't check the assignment
Yeah.
today.
Okay. You should check because it will
Yeah,
take.
it was showing me of 2nd September you have to submit, so I didn't check today. I'll submit it tomorrow, sir.
Okay. No need to submit now. I have already solved it. So from the next time you should try. So I am just saying that when you will download the question from the portal, so
Yes, sir.
the noting time that you are noting the question, so it will save our time. Okay.
Yes, sir. Yes.
So only solution is required, but you can get the questions from there. Question
Yes,
will
sir.
not be different. Question will be same always. But the solution is important because how I am solving, you should see the way I am solving.
So guys, hold on.
Yeah. You have to solve the equations like this
Yes,
and
sir.
this types of equation. You have to make your habit to solve the numericals. Okay. See, and these are just the previous year question of your exam, means CBSE exam. So these are the questions that has already asked in your exam. So you can consider that only these types of questions you will get in your exam. So if
Yes.
you are able to solve these questions, then you will get 100 out of 100. And the last question that I have solved is very, very, very important.
Yes, sir. So guys, hold on.
Okay.
Okay, next question.
Yeah. This question. First write this question.
Yes,
After
sir. Yes, sir.
this question is easy question, I will say. E suffix E means we have already discussed equivalent.
Equivalent.
EMF. And R equivalent means
Yeah, resistor. Resistivity. Equivalent resistivity.
Hmm.
So guys, hold on.
Yeah. Harsh, are you going school? Means has your school opened
Sir, it will open on Monday, sir.
from Monday?
Yes, sir. So guys, hold on.
So the time of your class will remain same after school, or will you change the time?
No, sir, same, sir. It was always the same, sir. Well, school was also there, but it was the same.
Okay, fine. I will say mark at least 2 or 3 star on this question. 2 star. This is 2-star question. See how much time it has appeared. 2008, 10, 15, 10. Then again, examiner is giving this question again and again because he or she knows that the student will get problem by solving this question, because this is a parallel combination of different cells. Parallel combination of different cells.
Yes, sir.
Yeah.
So guys, hold on.
Yeah. Harsh, do you have any book of physics?
Any book of physics?
Means,
Sir, I
do
have
you?
guide, sir. Oswald.
Okay. Uh, Theory is there.
Yes, sir. Theory, question answers, and boards.
And NCRT.
Yes, sir. NCERT also I have. So, yes, for
This question is looking lengthy for the when you solve it first time. Then when you will do revise of this question, when you solve this question second time, then this will be very easy for you. This is
Yes,
just
sir.
the this is in this question I will say 80% is the calculation, 20% is the concept. And always remember this V equivalent always equal to V. Is V equivalent always equal to V? Because in parallel combination, the potential difference on the terminal voltage will remain same.
See.
This is I2. So after this, we will have next topic, and we were discussing the combination of same cells,
Yes, sir.
identical cells.
Yes, sir.
Combination of identical cells, and we have already discussed the series and parallel combination of identical cells. Now we will discuss the mixed combination of identical cells. Okay.
Yes, sir. Identical.
And the meaning of the identical is the EMF and the internal resistance of the cell is same.
Same.
Yeah. And after the mixed combination of cell, we will solve one numerical, and after that we will have Kirchhoff's law.
Yes, sir.
This is R1 into R2.
R2.
Like
Yes, sir.
this is R1 into R2, and this is also
Yes, sir.
R1 into R2, R1 into R2.
Yes, sir. So, can you scroll down?
Yeah. So for the assignment, what you should do, you should go to the portal and at least download the questions. Okay,
Yes, sir.
download the questions. So and here when you come to the class, I will solve those questions. Okay, so
Yes, sir.
at that time you will only note down the answer. Okay, and you can manage that, which question have which answer, you can manage that. Okay,
Yes, yes, sir. Done, sir.
done. So write down the heading: mixed combination of identical cells. Mixed combination of identical cells. Identical cell we have and mixed combination we have. So in mixed combination, what I am going to do, first of all, all cells will be identical, and some cells will be connected in series and some cell will be connected in parallel. So this is the mixed combination. So in the mixed combination, see here how the mixed combination looks like. So suppose here I am connecting cell like this. Suppose I am connecting n cell in series. I am connecting n cells in series. So what I have done, we have identical cells. All cells are identical. Having EMF internal resistance. All cells. This cell also, this cell also, this cell also. All cells are identical. And one thing more. In this row, this is a row, na? In
Yes,
this
sir.
row,
Yes, sir.
n cells are connected. N cells in one row, n cells are connected in series. Connected in series. And there are m rows. There are m number of rows. This is one row. This and all rows have same n number of cells connected in series, and there are m rows. This is one row, second row, 3, 4, 5, 6, 7. So we have m rows, or you can say m identical rows. So here I will write n cells in a row in series, and there are a small m number of such identical rows. So what we will do, first we will calculate the equivalent resistance of equivalent internal resistance EMF of this row, then this row, then this row. So see here, I have already discussed this equivalent resistance, equivalent EMF and the equivalent internal resistance we have already discussed in the series combination. So what I have done here, this is connected. These are connected like this is one row, second row, third row. So what will the equivalent EMF of this row? NE, because N cells are connected. This is small n into E, and this is RE means NR. So this will NE, NR, NE, NR, and this is M times. Means these rows are connected M times. So now we have calculated the equivalent of this and this. Equivalent of first is this, equivalent of second row is this, equivalent of third row is this, and accordingly there are m number of rows. So now the m cells, now you can say m equivalent cells are connected in parallel. Now you can say m cells of EMF NE and internal resistance NR are connected in parallel. You can see from here, this is a parallel connection of this cell, this cell, this cell, and there are m such cells. So if you want to find the equivalent of this circuit, then you will find equivalent EMF is NE, because in parallel combination, and here one thing more, here you can just connect the resistance R also. A resistance R is also connected. External resistance, we always connect the external resistance with the cell. Harsh?
Yes, sir.
Yeah. So this is a R connected like this. Here also the R external resistance is connected. So, and if you want to find R equivalent, so for R equivalent you will write 1 upon NR, 1 upon NR. See, when you will calculate the equivalent of this circuit, so you will write 1 upon NR plus 1 upon NR plus 1 upon NR. This will, you will add M times. NR plus 1 upon NR plus 1 upon NR. You will add this M times. When you will add this M times, means you will get R equivalent. You will take the LCM NR. You will take the LCM NR. You will add 1 M times. So I have discussed in the last class, when you will add something like this, so here you will write M and here is NR. So from here you will get R equivalent as N R divided by M. So this is the equivalent internal resistance for mixed combination. Equivalent in the internal resistance for mixed combination. And this is the EMF for the mixed combination. So if you want to find the current in the circuit, if you want to find the current here, suppose the current is flowing like this. Current is flowing like this. I is the current. If you want to find the current, then you will write I is equal to E equivalent divided by R equivalent. And what is R equivalent? In total internal resistance plus external resistance. Total internal resistance is NR by M plus R. And what is E equivalent? E equivalent is NE. E equivalent is NE. This is NR divided by M plus R. So this is the current that will flow in the circuit. This will be the current that will flow in the circuit. And if you want to find, Harsh, I want to ask you one thing. Do you have maths or bio in your 12th?
Sir, bio, sir.
Okay, fine. So there is a term maxima and minima in 12th class mathematics. With the help of maxima and minima, we can find the maximum and the minimum value of a quantity. So if we want to find the maximum current for finding maximum current in circuit, we will use maxima and minima. This is a mathematical thing. So basically what we do in maxima and minima, I will giving you idea. I will just differentiate this equation of I with respect to I and put that equal to 0, then I will get the result, and then I will differentiate it again. If it is less than 0, then maxima will occur. If the equation will be greater than 0, then minima will occur. That is totally different thing. So I am not doing that. I am just writing directly. So when you will differentiate di divided by dr and put that equal to 0, you will get very interesting result. You will get NR is equal to MR. So you will get N by MR is equal to R. So what is this? This is the total internal resistance.
Yes, sir.
This is the total internal resistance of the cell. This
Okay.
is
Total internal resistance.
Total internal resistance of circuit, and this is external resistance. So if you want maximum current in the circuit, then you should have total internal resistance of the circuit equal to the external resistance of the circuit. So if right here, for maximum current, internal resistance and external resistance either equal or comparable. Comparable means if you have an internal resistance of 1 ohm and external resistance of 0.5 ohm. So these two resistances are comparable. So just copy this.
Yes, sir.
So this is the mixed combination of
Identical cells.
identical cells. when we will solve the question after this, you will get the things more clearly.
So you can scroll down. So you can scroll down. Done, sir.
We have this question now.
Yes, sir.
This question we will solve now.
So just a minute, note this one.
First, you should note this question and then we will discuss.
Yes, sir. Yes, sir. Done, sir.
Done. So just Harsh, I am giving you a break of 2 or 3 minutes. Just revise your mixed combination only. Okay.
Okay, sir.
And
Okay.
after that, no. Just revise series combination of identical cell, series combination, parallel combination of identical cell, and mixed combination of identical cell. And see the see in that specifically when the maximum current in all of these cases is happening. Okay. And just I am giving you 3 minutes because I don't want that to solve this question without the concept. Okay. First you should know the things, then we will move forward. So just take at least 2 minutes and revise that, and then I will solve this question. Okay.
Yes, sir.
Okay. Just revise that. Revise series, parallel, and just see
Mixed.
mixed.
Yes, sir.
Okay. And see the condition of maximum current in all the cases. And I have written the all these statements.
Yes,
So
sir.
yeah, you should see all these statements what I have written for the maximum current in series in parallel.
Yes, sir. Yes, sir. Done. Sir.
Okay. Are you ready now?
Yes, sir. Done, sir.
Okay.
Yes,
Okay,
sir.
fine. So just read the questions. We have given 8 cells, and these 8 cells of 2 volts and 1 ohm each means 8 here 8 cells are identical. Here 8 cells
Yes, sir.
are
Are
identical. Means each cell have
Same.
yeah, this is a cell, means having 2 volt EMF and
Yes,
1
sir.
ohm
Each.
internal
Yes, sir.
resistance each.
Resistance.
This types of 8 cells are given, and they are saying how would you combine them to get the maximum current.
Okay.
In the circuit, if external resistance is 100 ohm, and this thing is also very important. So they are saying external resistance is
100 ohm.
100 ohm. So for first external resistance means R is 100 ohm.
R is equal to 100 ohm.
And what is small r? Small r is 1 ohm.
1 ohm, sir.
So in the series combination, when you will go and if
Yes,
you
sir.
want, in this case, if you have identical cell and if
Yes,
you have
sir.
external resistance very much larger than internal
Internal
resistance.
resistance. We use the formula I is equal to NE by R.
Yeah, you are right. But I just want to say,
In
which
series combination, yes.
which combination will you prefer here? You will prefer.
The series, sir, because our external is much more higher.
Very good. Prefer series.
Yes, sir.
Means you will connect all the identical cell in series.
Series combination, sir.
So you will get the equivalent resistance, means you are connecting 8 resistances in series.
Yes, sir.
So you will get, very good. R equivalent you will get 8 ohm.
Yes,
and
sir.
what you will get, E equivalent, you will get, you are connecting N in a.
Yes, sir.
So what is N? N is 8.
8.
E is
2. 16, sir.
16. So finally, you have a circuit like this. You have a circuit like this. If you want to draw this is a cell having the internal resistance R, having equivalent resistance we have calculated, and R equivalent we have calculated, and we have the external resistance of 100 ohm this time. And equivalent we have 16.
Yes, sir.
This is volt, 16 volt.
Yes, sir. Volt, sir.
And R equivalent we have 8 ohm.
8 ohms.
And now this current will be the maximum current.
Yes, sir.
So we can find the maximum current, I max.
Yes, sir. 16 by 100.
16 divided by 100 plus
100.
8.
Yeah, 100 plus 8. Sorry. Yeah, internal is 16.
Yeah. So this will become 16 divided by 108 ampere. So this is the first answer.
Yes, sir.
Now for second answer, you have external resistance as 0.01.
Yes,
So now
sir. So external is much more less than internal.
Yeah. You have 0.01 ohm and internal resistance, what we have 1. So it means this time internal resistance is much greater than the external resistance.
External resistance.
So you will prefer parallel.
Parallel, sir. Yes.
Means you will connect all the cells in parallel combination.
Yes, sir.
You will connect all the cell in parallel
combination.
And what is the equivalent resistance in parallel combination?
R1 plus R, 1 by R1
R1
1 by R1 by R2.
You will write like this, so just write this R by N.
Yes,
okay.
R by N.
So R is 1 and N is 8.
8.
This is it. And what is E equivalent in parallel? E equivalent will remain same.
Yes, sir.
E equivalent will equal to E, that is equal to 2 volt.
Yes, sir.
Okay. So if you want to make the equivalent circuit, you have this cell, internal resistance R, you have this E equivalent, this is R equivalent, and you have connected this with an external resistance of 0.1 ohm. 0.1 ohm. So now you want to find the current, and that this current is maximum current.
Yes, sir.
So I max will be equal to this E. The value of E is 2.
Yes, sir.
Volt RE is 1 by 8.
Yes, sir.
So you will write 2 divided by
1 by 8.
1 by 8 plus 0.01.
0.019.
So when you will remove this, you will get 100 here. So this will become 800 into 2 divided by 100 plus 8.
100 plus
108. So when you will cancel this out, you will get 54, and when you will again cancel this out, you get 27. This is 400. So the answer will be 400 by
27
ampere. Okay.
Yes, sir.
So now second answer is also completed, but
yes,
now
sir.
This thing, now you should see this thing, third answer. Here external resistance is 0.5 ohm and internal resistance is
internal is much greater than
no means you can write R and R, they all are comparable.
Okay, comparable.
See, you can see the value here.
Yes,
this
sir,
R is 1, this is, they are comparable, so we will prefer mixed combination.
Okay.
Mixed combination of identical cells. Mixed combination. Now this is the question of maths. How? Because I am giving you 8 identical cells. and you have to decide from that 8 how many of those you will connect in series and how many of those you will connect in parallel. I don't know and you don't know. So what we will do, we are connecting n cells in series and m cells in parallel. Okay. So what was the equivalent of this R? We have already derived the formula, na?
Yes, sir. Yes, sir.
For RE, NR by M.
NR by M.
When n cell are connected. So N,
yes, sir. R
by
M.
M. So R equivalent, what N we don't know, M we don't know, what R we know. So this will become N by M. So R equivalent we have N divided by M. Okay. And R equivalent internal resistance can we calculate now? Total internal resistance R equivalent we can calculate, because we are connecting one thing more here is very important. One thing is very important here. For the maximum current, in mixed combination, one thing more I have told you. Internal resistance of the circuit is equal to the external resistance. Internal resistance is equal to external resistance for maximum current in, I have told you or not? Harsh, where are you? Oh. Okay. Okay, Harsh. So I have told you for the maximum current in mixed combination. Are you getting my voice now?
Sir, actually I got disconnected.
Okay, no problem. Are you now? Are you getting the voice?
Yes, sir.
Okay, fine. So we have already discussed that for maximum current in mixed combination, internal resistance, total internal resistance is equal to the external resistance.
Yes, sir.
So what is R? The RE is N by M. What is the external resistance in this case? External resistance is 0.5. 0.5 means 1 by 2. So you can write M is equal to 2N.
Yes, sir.
This is equation 1. You can say. This is equation 1. You can say. And one thing more, you have, how many cells you have in total? 8.
8.
So you are connecting M cells, N cells in series, M cells in parallel. So total cells you can write as M into N. Total cell will be M into N. M into N equal to 8. This is equation 1. And write this as equation 2. Now we will solve equation 1 and 2. 1 and 2. So what is equation 1? Equation 1 is this: M into N equal to 8.
Yes, sir.
So M into N equal to 8. So put the value of M in this equation 1. Put M is equal to 2N in equation 1. So now instead of this M, put this 2N. So write here 2N into N equal to 8. This will become 2N square is equal to 8. So N square is equal to 4. So N you will get 2. So if N is 2, then you will put N is equal to 2 in 1. So put N equal to 2 in 1. So you will get M is equal to 4. M is equal to 4. So these N cells we have connected in series. And M cells we have connected in parallel. Okay. Yes. So they are asking that 8 cells. Then how would you combine them to get the maximum current in the circuit? So you will say you will connect 2 cells. You will connect N equal to 2, means that is 2 cells you will connect in series, and M equal to 4, that is 4 cells you will connect in parallel. Now if you want to calculate the R equivalent, you want to calculate the maximum current. What will be the maximum current? Maximum current in the circuit is equivalent EMF.
Yes, sir.
Divided by the equivalent
resistance.
What is equivalent EMF? Means for the equivalent EMF, we have formula also.
Yes,
for the
sir.
equivalent EMF, for the mixed combination, equivalent EMF is this, NE. NE is the equivalent EMF.
Yes, sir.
Yeah. For equivalent EMF, I think I have already written. Not written. So for equivalent resistance, no. For equivalent EMF, we have NE. What is N? N is 8. E is 2. Means 16 volt is the equivalent EMF.
EMF, yes, sir.
And what is RE? RE is the
total internal.
Yeah, total internal resistance. This.
Yes,
N
sir.
by M. N by M plus external resistance means RE plus R. So RE is N by M plus R is 0.5. What is N? N is 2 by 4 plus 0.5. You will get this as 1. So total so for maximum current, you can write this EE divided by RE. What is EE? E is 16. RE is 1. So maximum current will be 16 ampere. Is it right or wrong?
It is right, sir.
It is right now, because
right.
this thing is the total EMF you have, and total for the total equivalent resistance. Okay, so you will have this. So in this way you can solve this question. I will say this question is quite a good question.
So you can just scroll down.
Yeah. So
sir, more sir, second one.
This now?
Second one, yes, sir.
Second or third? This is second. So solving a numerical. Move to third. Okay. Solving a numerical is completely different process.
Yes, sir. A little bit down, sir. More.
Okay, na? This?
Yes, the last part. Yes.
Okay. But you should know what is N, what is M, what is RE, all the symbols you should know. Otherwise, you will get confused here. Oh, this is ME. Oh, Harsh, we have done a mistake here. What mistake we have done actually? Total EMF we will have not NE, we will have ME. I am telling you why. ME. Why? I am telling you why this.
Oh yeah, the formula says it, right?
Yeah.
I was
is ME. Why? Because now you have connected two cells in series.
Yes,
you have connected two cells in series. Means this type of combination you will have. Means you have connected two cells in series and 2 volt, and 2 volt you will get 4 volt. Here also you will get 4 volt. Means total, means M cells, not M, NE, na? E equivalent is NE. So what is N? N is 2. 2. This is E is also 2. This is 4. So and RE is this is plus external resistance. This is 2 by 4. This is 0.5. 0.5. 1. So I is equal to EE divided by RE. So EE is 4 divided by 1. So answer will be 4 ampere. 4 ampere. Yeah.
Yes, sir. Okay. So can you scroll up where we were?
Scroll up. Okay.
Yes, sir.
So I think we will start the Kirchhoff law in the next class. In this class,
Yes.
I don't think we have enough time to start.
Sir, can I scroll down?
Okay. Okay, Harsh, we
Yes, sir.
can just introduce the Kirchhoff law. Can you handle it? Means
Sir, actually, my head is pain, sir.
okay, fine. I can I can feel your pain
Yes, I can
because
scroll down.
we are having the class of 1.5 hour, and I know that you are getting so much content in your mind. This is your mind, na?
Yes,
So
sir.
mind has its own capacity. So
Yes, sir.
we cannot stretch it. I cannot stretch it. But Harsh, are you watching She-Hulk?
No, sir.
Very good. Means you are going in right directions. And this topic is just this chapter is just going to end
Yes, sir.
in one or
Kirchhoff's law
two.
is last.
Kirchhoff law is last, and after that, a topic which is very close to my heart, I will say magnetism. The
Okay.
topic is very much close to my heart when I was in 12th class, and at that time I faced difficulties in the direction because in magnetism
Yes, sir.
everyone can find the magnitude, but in direction like this law and this hand, right hand thumb rule and Fleming's left hand rule, these are the confusions. So what I have done, I have tried that I have made the content and I have tried that you and all of my students that are studying with me will not face the difficulties and they will feel that it is very easy chapter like
Yes,
1 plus 1 equal to 2. I okay.
done, sir.
Yeah. Okay. Done now. And Harsh,
Yes.
I am just saying that next topic will be Kirchhoff law.
Yes,
So
sir.
I don't want to extend the class. I'm just giving you something, telling you something because Kirchhoff law is a little bit lengthy topic.
Yes, sir.
So when coming to the next class, please be prepared for it.
Yes, sir. Of course.
Be prepared for it. Okay.
Okay.
Because Kirchhoff law, we will have a lengthy moment. And
Okay.
one thing more I want to tell you, if you are facing any kind of problem in physics and if you
Yes,
have
sir.
the doubt and all that, and if you are not satisfied with my teaching style and teaching way, then you can ask me and you can just say me, and you are always free to say any not anything means the thing the thing which are good for your study you can
Yes, sir.
say. And
Okay.
one thing more I want to add here that at least in a week you should revise your note 2 times.
Yes,
and
sir.
and then the meaning of revision is not like this you have a headphone in your ear and you are listening the music and just writing it like this. No, you have to revise the things properly. Okay.
Yes, sir.
And
Yes, sir.
just I have given the assignment like this. Here I have given the assignment, I think this assignment na?
Yes, sir.
So I have solved the question. I can solve this question even in 1 minute also. No problem for me because I am solving it again and again. But what you should do, you should take this question and try to find the solution by yourself.
Yes, sir.
Don't see here and there in the book, in that book. Try to think by yourself. After revising the my notes, you can just try. And when you will try to solve the problems, because if you will solve the problems, then you will get better in that. Suppose if you want to be a footballer, then will you play cricket or football?
Football,
You will
sir.
play, of course, you will play the football. And for playing the football, you should know the rules of football, how to
Yes,
play
sir.
football.
Yes,
And
sir.
for excel in football, for developing the skills in football, what you should do? You will do the
Practice.
practice.
Yes,
So
sir.
same is the case applied here in the study also. And this is
Yes.
only for 1 year. After the 1 year, if you will become a doctor, then there will be no physics.
Yes, sir.
Yeah, if you be a doctor, because I am telling now, my elder brother is a doctor, so now he was very good in physics, but now no physics. So there is nothing permanent in life. Physics is also not the permanent. So just bear it for just till the date of your examination. Then you will come out of the examination, and physics will disappear from your life. But
Yes,
but
sir.
but the thing will remain with you. The thinking that you